Good morning. Today we're going to be working on ratios and rates. We're going to define and write our ratios and rates. We're going to simplify our ratios and rates to lowest terms, and we're going to use ratio and rates to solve real life problems. A ratio. Now, a ratio is a comparison of two or more numbers and can be written in three ways. For example, the ratio 9 cents to 13 cents can be written in fraction form, 9/13, or colon form. This is also the standard form. So if you're ever asked to write in the standard form, you're going to use a colon, 9:13. It can also be written in word terms. So we can use the word 2, 9 to 13, or in the actual words, 9 to 13. Now, a ratio should always be simplified. For example, the ratio of 15 to 40 can be simplified by reducing the numerator, or the top and the bottom number, by 5. And that would give me 3/8. So instead of saying, oh, that's 15 out of 40, it's more reasonable to say it's 3 out of 8. That way people can visualize your ratio. Now, unlike in fractions, when you are reducing a ratio where the top number is larger than the bottom number, you're not going to be making a mixed number, because this improper fraction is really a ratio, so all I'm going to do is reduce it. Because I have to compare it, I have to leave it improper, okay? So I can reduce 28/7 by 7, and I'm going to leave it as 4 to 1, because you have to have that comparison. You're not going to just use the number 4, okay? A ratio should never be made into a mixed number or a whole number. Here's another example. You have the ratio 20 to 1. You can write it in fraction form. You can write it in standard form, or you can write it in word form using 2. Do not use 20 and call it a ratio, okay? It's not the right definition. You have to have at least 2 numbers there. So if I have the ratio 33 to 6, I need to reduce this one also by 3. And when I do that, I will get 11 to 2. You will not use the mixed number 5.5, because we're not talking about fractions. We're talking about ratios that need to have a comparison, 11 to 2. Now, a ratio must be written based on how the question is ordering it. So even though the word problem may be wording it one way, you need to focus on the question in order to write it properly. So in this example, your school's basketball team has lost 3 games and won 7. What is the ratio of wins to losses? Now, in the word problem, the losses were listed first and then the wins, but we have to list it as wins to losses. What I like to do is write down what the question is actually asking for in the ratio before I actually put the numbers there. So I need to know games won to games lost. Now, because you're comparing these wins to losses, the first number in our ratio should be the number of wins, and the second number is going to be the number of losses. So we know that they won 7 and they lost 3. So my ratio is 7 to 3. A ratio with decimals are easy to compute. You can use a shortcut, and I'll show you how we do that. Let's say that you have some pears that cost $1.15 a pound, and you have some apples that cost 95 cents a pound. What is the ratio of the cost of apples to the cost of pears? Well, just like we did before, we're going to put apples and then pears based on the actual question. We know that those apples are 95 cents, and we know the pears are $1.15. Now, since I have two decimals here and two decimals here, I can just move my decimals two places to the right, two places to the right. That's the same as multiplying by 100. It's just a shortcut. And then, because both of these end with 5, I can divide by 5, and I get the ratio of 19 to 23. So you're just moving your decimal over two places, which is the same as multiplying by 100, to actually get it to a form that's easy to reduce. Now, ratios in the same category of measure must be changed to the same unit of measure and simplified. And what I mean by this is if you're talking about capacity like teaspoons and tablespoons, or you're talking about cups compared to pints or gallons, you need to get them in the same unit so that you can write a ratio that reflects the true nature of the ratio, okay? So in this example here we have, what is the simplified ratio of 1 3/4 pints to 14 cups? We know that pints and cups are both capacity liquid volume. They're in the same category of measure. So the first thing you want to do is you want to change your pints to cups. So we know a pint has 2 cups in it. So when a pint has 2 cups in it, we're just going to take 1 3/4 and multiply it by 2. We get 7/4 for the number of cups in this particular problem. And then we take that 7/2, now that it's reflecting the right unit, and we're going to multiply it by 14. Now when we do that, we took 1 3/4 pints because that's what they listed first, and we're going to compare that to the 14 cups. When I convert this to cups, I'm going to get 7/2 is 14. I take the 7/2, I multiply it by the 1/14, and the reason why I flipped it is because there's a division here, and remember when dividing a fraction, you need to do keep, switch, and flip. So we kept the first one, we switched the operation from division to multiplication, and then we inverted or flipped the whole number 14, which can be written as 14/1, and flipped it to 1/14. Now once I cancel, 7 goes into 7 once and 7 goes into 14 2 times. That leaves me with 2 times 2 is 4, and my answer is 1 to 4. If you're not real familiar with the customary measures, I do have a chart that you can look at for converting those. But if you're in the same unit of measure, you really do need to convert them to one measurement and then reduce it down so that you can have a ratio that reflects the right measurement. Now let's talk about rates. A rate is a ratio. The only thing that's unique about rates is that they have 2 different units of measure. And a rate can be written like a ratio in all 3 forms or described as a per unit. We use this all the time in real life. So for example, the rate of $4 to 1 calculator can be written $4 to 1 for slash calculator. This is the fractional format. Or the words for to a calculator. So those are the same forms that we use for ratios. Also, in many instances, we can use the per form, which means $4 per calculator. Still going to look like a ratio. If you were to write it as a fraction, it would be a slash. Some teachers require that you have the slash. I don't, because in real practical use of rates, we use the word per to indicate a slash, okay? So it's okay with me. So when we're using rates, there's a couple of different unique things. A rate should always be simplified, just like a ratio. For example, if I had the rate 34 degrees to 2 readings, I can simplify this by reducing these two numbers as with a 2. And when I do that, it's more practical to say that I have 17 degrees per reading, or per one reading. And remember, per can be the substitute for the line here. And this is the way we would actually say it in application. Here's another example. The rate of $1.20 to 4 pence can be simplified. We want to know the unit rate, so we're just going to basically divide 4 into $1.20. If you want to reduce it, you can just divide it by 4, and that will give you 30 cents per pen. And we would actually say it as 30 cents per pen, like this, or 30 cents for each pen. Now remember, in a ratio, if the numerator and denominator are measured in different units, then the ratio is called a rate. Write your rates in the order stated in the question. A unit rate is a rate per one given unit, like 60 miles per 1 hour. Here's an example. You can travel 1,200 miles and 60 gallons of gas. What is your fuel efficiency in miles per gallon? So you need to do the miles first, the gallons on the bottom, and you can either simply reduce that or just divide it. So if we divide it, 60 goes into 1,200, 20 times per 1 gallon. Another way that we would say this in actual application is 20 miles per hour, or 20 mpg would be the abbreviation. Oh, I'm sorry, 20 miles per gallon, or 20 mpgs for miles per gallon, okay? I'm so used to miles per hour when we use this in practical. But gallons counts too. Another way to solve this unit rate is what we call the 3-step method, and this is like a precursor to how to solve a proportion, which we'll be talking about next. First, set up your rates with what you know. Look crossways and multiply the two real numbers. Finally, divide the product in step 2 by the number that's left over. So let me give you a quick example of this. It's pretty easy to remember. And then the saying that I use for this is set it up, cross multiply, divide. Try to practice that. Set it up, cross multiply, divide. Here's an example. Now in this example, the temperature change was 1 degree in 1.5 hours. What is the temperature change in 1 hour? So we have to first set this up. We have degrees and we have hours. So in my setup, I'm going to have degree and hour. They said that 1 degree changes in 1.5 hours. What they want me to find out is what happens in 1 hour. Now, one thing you want to do when you're setting this up is keep the same units on the same row. So my top row I wrote down was 1 degree, and so this whole row is degrees. And I have the 1 degree and the unknown degree that I have to find. And then on the second row, I wrote hours. You could have put the hours here and the degrees here. Just keep the same units on the same row to make sure that they're proportionate. So when I look crossways here and here, I don't have two real numbers in this situation, but I do have two real numbers here. I know that 1 times 1 is 1. Then I need to take that 1 and divide it by 1.5 hours. Since this is a fraction, we're going to keep, switch, and flip, and I get 2/3, or basically 2/3 of a degree is the change that I have in 1 hour. Okay, so some people might want to write this as 0.67 per hour, but to me it makes more sense just to say 2/3 of a degree. So rates, to compare unit rates, you can just divide, just like we would do if we were comparing prices in the store. So in this example, which is the best buy or the better buy? 3 blanket throws for $25.99 or 2 blanket throws for $16.50. And then once you get your division answer, you should round it to the nearest cent, which is 2 decimal places, or the hundredths place, because hundreds and cente means the same thing. Now, I've had a student who thought that better buy, she was from a different country, she thought that better buy meant better quality. Now, just for the sake of this problem and many of the pricing problems that I will have regarding rates and ratios and proportions, the better buy is the cheapest price. Okay, so what is the cheapest price? I'm not going to talk about quality, but quality does count when you're really buying it in real life. Okay, so just kind of ignore the quality for this question. I'm going to take the $25.99 and divide that by 3 because there's 3 blankets. So for me to get the unit rate, that'll tell me what it is for one of them. And then for the 2 blankets, I'm going to divide 2 into $16.50. And then that'll tell me which price is going to be the cheapest. Now when I do that, I get $8.66 per blanket for the first choice of 3 blankets for $25.99. I'm going to compare that to 2 blankets at $16.50, which is $8.25. So most people would think that having the 3 blankets should be cheaper, but in actuality it is cheaper to buy the 2 blanket packet because those blankets are only $8.25. These blankets are $8.66. So the better buy would be the $8.25 per blanket. Your second choice is the cheaper choice. Now, I want to give you some sort of testing choices that you can do too, because you'll see these show up on the GED exam. You'll see ratios and rates show up on a lot of different standardized tests. But in real life, we do this all the time too. So Carol mixes 6 cups of lettuce and 2 cups of tomatoes in her salad. What is the ratio in cups of tomatoes to lettuce in her salad? So 6 cups of lettuce, 2 cups of tomatoes. They want tomatoes to lettuce. That would be 2 to 6. But is that simplified? No. 2 to 6 can be reduced by 2. So 2 goes into 2 once, and 2 goes into 6 3 times. So the best answer, after we read this and we gather our needed information, and this is a strategy you can use when you're using word problems. Read to understand, gather the needed information, and then do your plan. So the ratio we got was 1 to 3. You can always check it if you have time. Here's another example. Larry has 5 $1 bills, 4 $10 bills, 2 $5 bills. What is the rate? In what ratio does Larry have $10 bills to the total bills? So first we have to make sure that we focus on the question. How many $10 bills compared to the total bills? So we need to add up. That would be the plan, is to add up how many total bills he's got. So we have 5, 4, and 2, and when we add that up, we get 11. Then we need to write the ratio the way that the question is asking. And the number of $10 bills was 4 when you look up here. So in our plan, let me get caught up here. We need to take the 11 and write our ratio is 4 to 11 because they care about the $10 bills. And you can always check it. So that's the correct answer, number 2 here, 4 to 11. Mike bought salmon on sale. He paid $27.60 for 3 pounds. Find the rate. What was the price per pound? And remember, I told you you can just simply divide to solve those problems. So we're going to gather the information, the $27.60 and the 3 pounds. The plan will be to actually divide it to find the unit rate. And once you do that, you solve it. And the answer we got was $9.20, which is number 3. And then, of course, you can check it by using multiplication. Question 4. A small gear in a machine makes 80 RPMs, means revolutions per minute, and a large gear in the same machine makes 25 revolutions per minute. What is the ratio of the smaller gear's RPM to the larger gear's RPM? So these are the choices in the problem. Let's actually see what the plan is. We've got 80 and 25. They want it in the ratio of the smaller to the larger, which will give me that the 80 and 25. Then you want to put it in the right ratio of smaller to larger, because you know a smaller gear is going to turn faster than a larger one. And when we simplify it by 5, we get 16 to 5. So the answer is number 5 here that says 16 to 5. Okay, and you can always check it. A lot of times when you're taking a test, you might not have time to use the operation to check it. You can just try to use your logic. Example 5. On a math test, there are 20 fraction problems, 15 decimal problems, and 15 rate problems. What is the ratio of the rate problems to the total number of questions? So let's gather up the information. They want us to focus on the rate problems to the total questions. And we have 20, 15, and 15. Looks like it's 50 questions total. So after we add them up, we're going to write the ratio and then reduce. That's the plan. So of that, rate problems was 15. So we're going to say 15 to 50. But we can't leave our answer as 15 to 50. It must be simplified. So when we reduce this by 5, we get 3/10, which is problem answer number 3. And you can use multiplication to check it if you need to, since we divide it. Question 6 example. There are 30 people at a meeting, 18 of them are women. What is the ratio of men to women? Now, you know in this problem they didn't tell you how many men there were. So in your plan, you need to find out the number of men. So you gather up the information. There were 30 total people, 18 were women. And then your plan should be to take the 30 and subtract 18, find out how many men you have, and then set up your ratio. So when we subtract 30 minus 18, we get 12. The ratio of men to women is 12 to 18, but this can be reduced by 6. 6 goes into 12 2 times, and 6 goes into 18 3 times, so the ratio is 2 to 3. And you can check that with multiplication since you did division to reduce it. So in summary, a rate is a ratio with different units of measures. Rates can be written in 3 different ways, like a ratio, in a fractional form, a colon, or standard form, or using the word to. Rates can also be written in the per unit form, like 30 kilometers per hour or 30 kph. Simplify rates to lowest terms. Find rates to 1 unit. Rates must be written as ordered by the question. Another way to solve rates, which is very similar to solving proportions, is you will set it up, cross multiply, divide. Remember to keep the same unit on the same row. Rate comparisons can be quickly divided when compared for the best buy. Remember that means the cheapest price per unit. And use rates to solve real life problems. What I'd like you to do is go to your study guide, work on the problems that are there, and then if you have any questions, please let me know.